dev services, one for Ollama, one for the observability platform, and one for Postgres. And that means that whenever I run my application with Gradle or Maven, standard command, then I will get all these services started up for me as well. So I don't have to worry about any external dependencies or about preliminary steps. I just run my application and all these services are provided for me. So let's have a look at this application. As I said, I have a standard Spring Boot application. I defined already an empty controller class annotated with REST controller. And here the key ingredient is using one of the main APIs from Spring AI. It's called Chat Client. Chat Client performs requests to an AI model. So it offers a nice and fluent API. And we can build an instance. So we are not auto-wiring directly a client, but we are injecting here a builder. This is auto-configured for us. And then I use the builder to build my specific instance. So what do we do with this chat client? Now, the first thing we can do down here is that we can accept a prompt from the user, a query, and then we can call the model, and we can get back the content of the response from the model. I'm not configuring anything specific here, so I'm using all the default configuration. I have Ollama set up, and in my application YAML file, I defined a default model for it. So we can see here, by default, I'm going to use the Granite 4 model that I have previously downloaded. But you don't even need to download this model beforehand because Spring AI can take care of that for you. So you can configure this init property so that whenever a model is missing, Spring AI will download it for you at startup time. So you don't have to worry about downloading all the necessary models beforehand. It can do that for you. All right. Now, I need to run my application. So I'll show you it's a standard Spring Boot application with Vaadin for the UI. So I'll run it from the main method. Nothing special here. Now, since I'm starting the application for the first time, it's going to set up all those dependencies that I need, the database and observability platform. And once it's done, we can try out this endpoint and see if it works. All right, the application is running. We can see the UI in here, but let's start from the terminal first. So it's running on port 8080. The endpoint is API/chat, and let's pass a query. For example, what is Java? Tell me in one sentence, like that. And I get the response back in one sentence, which seems pretty accurate. Good. So I've just interacted with the model through my Spring Boot application using this chat client API that is provided for me by Spring AI. Now, this is very, very simple. Let's start to improve the prompt capabilities because we can do much more than just asking simple questions. So I'm going to get rid of that, and I'm going to break down the prompt into two parts now. One part is called the system message. That's actually the way that we provide instructions for the model. So we could say like this. We could say answer every question as a rock star. And then we pass the user question as a user message. So we are breaking down the prompt into two parts. We have a system message. That's the instruction to the model. And then we have a user message. That's the actual question that every time we ask in a different way. But the instruction will stay the same. So we have a consistent behavior. Let's see. Same question. What is Java? And did it start again? Let me check. Yes, it's not answering as a rock star. That's really disappointing. So let's try something else. I'll answer every question as a rock star and end the answer with rock and roll. All right. Let's do that. So I'm using something called Spring Boot DevTools. So whenever I make a change, it will reload the application for me. So I'm not restarting my application automatically. Okay, this one is good. Rock and roll. All right, could be better. But this is a way we can provide instruction programmatically. So we don't want to give full power to the user by specifying all the instructions in the prompt, but we want to break that down into parts. We could even define a template. So for this example, I'm going to remove the system message. And instead, I'm going to customize the user message in a way, let's see. So I'll define a template that I can fill out with information from the user. And this template could be give me information about the language. So maybe I want to use this tool in order to get information about some programming languages. But instead of letting the user decide the entire question, I'm going to define the prompt inside the application. And then I will ask the user just to provide a language information like this. So I'll define a template. And then, of course, I need to remember to replace it. So I will replace the language placeholder with the actual language value. So now every time I ask a question, I can simply say API chat language equal Java, like this. But then the model will see the full question, give me information about the Java language. And I haven't specified in one answer, in one sentence, so it's going to be a longer answer. But it's working. Now, what's happening under the hood is really important here. That's why I set up observability right away. And because I used Arconia OpenTelemetry starter, this dependency here, I will get full observability out of the box, compatible with OpenTelemetry. And as I said, I'm using a dev service to spin up an observability platform. It's called Phoenix. Let's have a look here. So this is specialized for AI application. And from here, I want to show you what is happening under the hood whenever I ask the model a question. I can see that there is a chat client involved from Spring AI. That's the parent concept that we are using to perform these flows. And at the end, we are calling a model. The model is using Ollama, Granite 4, 3B. This is a model, an open source model from IBM. But this platform knows about Ollama, so it even shows a nice icon in here. I can see the input message, give me information about the Java language. So this is the template processed with my input as a user. And I can see the answer from the model. I can also get more information about the tokens that I spent as input and output and the cost. Now I'm running everything locally, so I'm actually doing all of these for free, which is nice. All right. Now, on top of this setup in here, I can start doing something a bit more complicated, because so far I've been working with strings, but typically in an application, we want to work with more structured data. We work with Java objects. We don't work with plain text. So what I can do here is defining a Java record to hold my model. Let's call it language info. And we can have a name, a description, something like this. And now, instead of returning simple text, I want to return a language info object. So I will replace this with a call to entity, like this. And now this controller will return an object of type language info. Let me also add here answer in one sentence. All right. So what's happening here? I'm still asking the same exact question. Let me make sure that I'm getting the correct answer. But now I'm getting a structured object. So it's a language info object. In Java, I can work with it as a standard Java object. And of course, now I'm returning it through an HTTP endpoint, so I will get the JSON representation. How does this work? Because a large language model only works with text. So we are always exchanging free text between the application and the model. So in order to get this response in a structured way, we need to instruct the model on how to format the response. So I could do it in the prompt myself. So I could add information about the language info record, that there is a name, there is a description. But that's something I wouldn't want to do as a developer. Like it's lots of work. Instead, Spring AI can do that for you. So whenever we specify that we want to return an entity instead of just textual content, Spring AI will augment the prompt for you. And once again, we can check in here in the, yes, I think it's this one. So we can see our original question, give me information about the Java language, answer in one sentence. But this is not the full prompt that we're sending to the model, because if we check the call to the model, the question is actually longer. So we have our original question, but Spring AI has augmented the prompt for us with information about how to format the output. So it says your response should be in JSON format. It's even included a JSON schema specification of our object. So we can see we have a description property of type string. We have a name property of type string. So all of this is provided for us by Spring AI. So we don't have to worry about it. And the output will be JSON. This is what we call a structured output. So it's really useful because most of the times we want to work with structured data because we add these calls to a model as part of a programmatic workflow. Of course, if we want to have a chat interface, we're going to work with text. And that's what we can do through our Vaadin UI. So now I'll move from here to my other service that exposes a UI. It's called the demo service, where I also have a chat client in there. So let's give it a go. There it is. So I have a chatbot in here. I can say something like, hi, I'm Thomas. And I get an answer back. Hello, Thomas, it's nice to meet you. And then I can ask, what's my name? Okay, the model doesn't know. As an AI, I don't have access to personal data. What's happening here? The problem is that the model, all the interactions with the model are stateless. So there is no memory involved. Every time I ask the model a question, the model doesn't know about all the past conversation we had. It's a mathematical function. We pass some input, we get some output, and there is no state, there is no memory. So that's something we need to provide as a user or application developers. Like as a user here, what I could do is, let me try this again. So I could say, hi, I'm Thomas. And then I can ask, what's my name? But then I need to tell the model about the past conversation. Again, there's no memory. The model doesn't know. So I'll have to copy all the past conversation and include it in the prompt like this. And now expect the model to answer correctly. Let's see. Yeah, as mentioned in our previous conversation, your name is Thomas. Of course, this is not something we want to do every time we ask a question. So we have something in the application that we can do. So single interaction that we've done at the beginning, we propagate the question to the inference service, we get back some response. We can add some structured output, as we saw, but there is no memory. So if we want to add some memory, we need to do something within the application so that we don't have to ask the user to always paste in the past conversation. So we can do it by intercepting the request to the model. We can intercept it when asking the question so that we can obtain all the past conversation from the memory and augment the prompt with the memory. But we also need to remember whenever we get the response back that we update the memory with the new messages that we have exchanged. Now, we could do this programmatically as part of the code, but Spring AI provides a nice way of obtaining this behavior out of the box. And it's based on an API called Advisor. An advisor is an interceptor, so that whenever we send a prompt to an inference service, we can intercept that request and do some preliminary tasks. And in the same way, whenever we get the response back, before returning that response to the user, we can also do some post-processing. So let's see how that works. Instead of building a standard chat client here, I'm gonna add our first advisor for the day. So it's an interceptor, and there is one called message chat memory advisor, like this. Let's build it. Now, of course, if we want to keep something in memory, we need to provide the memory, right? So I need to provide an object of type chat memory. This API is provided by Spring AI. There are different implementations. By default, you get an in-memory implementation. That's what I'm using now. But you can have Redis, you can have MongoDB, Cassandra, Postgres. So, or you can plug in even your custom memory. But anyway, so what we do here is that we add this advisor so that whenever we have an interaction with a model, we keep updating the memory and including the past conversation in every new message. However, we can have multiple conversations. So we need a way to identify these conversations. That's why I need to provide a conversation ID. Typically, that's something related to the user. So if you're using Spring Security, you can use the currently authenticated user identity in order to distinguish between different conversations. In this case, it's a simple example. So I'm just defining it as a constant here. And then whenever I call the chat client, I need to provide that parameter to the chat memory. So that's how the chat memory knows where to retrieve the specific conversation. So with this addition, we can try this again. Hi, I'm Thomas. Now if I ask what's my name, hopefully it answers. All right. Now that we have memory, we can start asking more and more questions. For example, I mentioned that I'm using something called Arconia Dev Services. That's a library I built very recently, but the model only knows about information used during the training process. And I know that the model I'm using right now was not trained on information from this year. So probably if I ask what are Arconia Dev Services, you won't know. So there are two possible outcomes. The best case scenario is that the model just tells me, hey, I don't know. The worst case scenario, and that's the typical one, unfortunately, is that the model will just make something up. So it will give me a wrong answer, but very, very confidently. Let's see. There it is. So very, very confidently is telling me something about, yeah, that's wrong. So this is very, very wrong. So how can we fix this? How can I ask a question about something that the model was not trained on? Remember, at the beginning, I talked about preparing data and training a model on data. The model only knows about the data that it has been trained on. So in this case, I would think of going and use a search engine. So I could use a search engine for Arconia Dev Services. And I can find here the blog post I wrote about it a few weeks ago. So I know that this blog post contains the answer. I also know where to find the answer. So I'm gonna copy this. And in my prompt, let me refresh that. Then I'll ask my question again, what are dev services? And then I'll provide the context by pasting the results from the search that I've done. Let's see. All right. So now the model knows a bit more about the Arconia Dev Services, at least as much as I included information in the prompt. What I'm doing here is not dissimilar to what I've done previously for the memory. It's called prompt stuffing. So every time we ask a question, we are also providing the context to the model. And of course, this is not a great user experience because I don't want to go and search all this contextual information for the model to answer a question. So what we can do is getting rid of the context as a requirement for the user and adopt a pattern called Retrieval-Augmented Generation. So inside the application, what we want to do is intercept the request to the model and augment the prompt with contextual data. Now the question is, where is the context coming from? In the example we just saw, the context came from a web search engine result. So we could think of including a search engine and retrieving context from a search engine. There are several search engines that offer an HTTP API that can be called from RAG applications, just like this one. So we could give it a go. And once again, we can use the concept of an advisor in Spring AI because It's the same pattern as with the memory. We are intercepting the request and performing some manipulation of the prompt. So back to the code. Let me remove the chat memory. We'll not need it for now. Instead, I'm going to add an advisor, very conveniently called Retrieval-Augmentation Advisor. Let's build it like this. So this advisor is used to define these flows that perform retrieval-augmented generation steps. It's very modular, so you can plug in different components here. Now, the most simple approach is called a naive flow, and it requires at least to provide some contextual source to retrieve the data. And we retrieve it and parse it as a document. Document is an API provided by Spring AI. It's just a common way of identifying any type of data. And since I'm using a search engine, I'm gonna build a search engine document retriever. Now, since the search engine is available through an HTTP API, I'm gonna use Spring Framework's own REST client to do that. So I'm gonna inject here the REST client builder, which is auto configured for me, REST client builder. So you can see it's the same pattern as chat client, REST client. They all follow the same pattern as Spring, which is great. And perfect. So now, whenever I send a request, this advisor kicks in order to retrieve context from a search engine and include that context in the prompt. So the model knows information from the search result. Let me try asking what are our cognitive service and see what happens. It's taking a bit longer, of course, because now we have two calls to external systems. The first call to the web search engine and the second call to Ollama. All right. It also seems a very correct answer. We are using some of these cognitive services. We're using Ollama, Phoenix, we're using Postgres. Great. Let's see what happened under the hood. That's very important in order to understand and to tune the behavior so that if we are not getting the expected result, we know how to fix it. So we have our good old chat client. Our original request is what are our cognitive services? But then before calling the model, we have a step for retrieval augmentation that involves calling a search engine. Now this step is augmenting the prompt. So the final prompt, we can see that includes lots of context information. That's a long list. By default, I think the top 5 results from the search are included in here. And at the end of this very long prompt, we'll find the instruction. Given the context information and no prior knowledge, answer the query. Follow these rules, and the query is, what are our cognitive services? At that point, the model knows everything it needs to know to give me a correct answer. Now, we can extend this process because what we're doing is intercepting a prompt and retrieving context from other places. So what if we want to integrate context from our own data? In our companies, we might have lots of data in different formats. We might have PDF documents, Microsoft Office documents, PowerPoint, Office images, maybe, or even screenshots or photos of some documents. Or it can be perhaps audio recordings of important meetings. So we could get data from lots of different sources. So if we really want to integrate our own data with this application, we need to solve the first challenge, which is gathering and extracting all this information in a unified way so that we can deal with different types of documents in a consistent way, no matter the original input format. And then the second challenge is we need to store this information in a way that whenever we want to augment the prompt with the context, we can retrieve just what is relevant. So the process that I've done earlier manually, going to a blog post and just copying part of the article, I cannot do that manually every time I want to retrieve data from my own database or from my own pile of PDF documents. So I need a way for the application to dynamically retrieve only what is relevant to answer a specific question. So for that goal, what we are doing is converting all these documents into a representation called embedding, which is what enables what we call semantic search. So we store all these embeddings or vectors in a database. It could be a dedicated vector store, but you can store this type of information in your general purpose database. For example, I'm using PostgreSQL, which is perfectly capable of storing embeddings. And once we do that, we can perform a semantic search. So we are searching by the meaning of a text. That's a way that we can retrieve only what is relevant based on the question. So if I ask a question about Java, I don't want to retrieve all documents that talk about Golang and vice versa. That's why we need semantic search. So let's have a look at how it works. We have these two steps. First, we need to prepare the data and store them in the vector store. So we need a data ingestion pipeline. Spring AI provides three main APIs to build this pipeline. The first is a document reader abstraction. That's how we read data from different sources, PDF documents, markdown files, web pages, audio files. Then we optionally go through a transformation step. For example, if we have a document which is too big, we can turn it into smaller chunks because they are more easily parsable and usable inside our RAG flow. And finally, we write them in a dedicated store as embeddings. So that's how a machine can tell what's the topic of a certain text, performing semantic search. Now, we gonna use PostgreSQL as a vector store. I just mentioned that. We already have a way to consume large language models with Ollama. What we are missing in our application is a way to read and process different types of documents. Spring AI offers this API called Document Reader. So we can find it. Let me open the other file. So we can find different implementations. For example, we have a Markdown document reader implementation to read Markdown files. We have a JSON document reader. I think it's just called reader, yes. To read JSON files, we have a text reader to read simple text. Maybe it's a PDF. We have a PDF document reader. We also have some more generic reader. We're using Apache Tika. We have a Tika document reader. Now, the problem is that we might need to deal with a lot of different types of documents. So we need to have a consistent and safe way to get good results no matter what's the input type. So I want to introduce something quite new in the Java space. It's a tool called Docling. Docling is an open source tool started at IBM and later donated to the Linux Foundation. And the main job that Docling does is preparing documents for your GenAI and RAG applications. So it can process, you can see from the picture, any types of documents and make it ready in a structured way for different types of activities, including doing retrieval-augmented generation, because it converts all these documents into a unified format called the Docling document that we can integrate into our application. So instead of using specific document readers, what I've tried to do is using Docling to perform that. Now, Docling is a Python project, but we recently started a Docling Java project on GitHub. Just last week, the first release was out, and I used this Docling Java project to build a Spring Boot integration as part of my Arconia project. So I'm going to use now Arconia Docling. This is brand new. I've actually performed this integration earlier today, so it's really brand new. And what I'm doing in this ingestion pipeline is using something I built called a Docling document reader. So this is an implementation of document reader that delegates all this processing of documents to Docling. I'm using the Docling Java SDK, which offers this Docling Serve API to call Docling. And then I'm delegating Docling to process documents. In this case, I have some stories here, story 1, story 2. So there are stories about different characters. So we can ask questions about those stories. And in the end, I'm splitting them into chunks so they can be handled more easily as part of my workflow. And finally, I'm storing them in vector store. So I have three steps. One, I'm reading documents and I'm using docling for doing that. Second, I'm manipulating those documents. In this case, I'm splitting them up into chunks so I can handle them easily. And finally, I'm storing them in a vector store. Now, this vector store is PostgreSQL, as I told you. So this is an abstraction from Spring AI. You can replace it with any other data store that supports vectors. But I'm not storing these documents as text or as binary file. I'm storing them as embeddings. So what happens under the hood, it's really important to understand. So let me show you an example. I have here an endpoint to generate an embedding starting from some text. So I'm gonna need actually an embedding model. So this is a dedicated abstraction in Spring AI to call an embedding model. And I need to auto-wire it in here like that. Cool. Now down here, I can say embed, passing the query, and let's see what we get back. So we're getting back this array of floating point numbers. That's our vector. API embed, and then the query will be Java. All right. So now the next time you see this array, you can recognize that means Java, right? This is definitely not for humans to understand, but the machine can use it to perform this similarity search. So in the database, I have all this type of information for all my data. So now in my service, I can actually replace the search engine document retriever with a vector store document retriever. So now I'm retrieving all this contextual data from a vector store. The pipeline created the data, and now let's see if it's working. So back to this. It's reloading. Now, by the way, Docling is running as a container as well. So I have a dev service that starts a Docling service for me. So I can actually show you the UI in a second. Why is the application not starting? There it is. So let me ask a question about one of the stories. What is Yorek's dream? That's one of the characters in the stories from my own data. Let's see. Okay, this is correct. Yorek dreamed of going to the North Pole and seeing the Northern Lights. So Docling, as I said, I'm using it to process the data, and I can show you that it's running as a container. We can even get a nice UI. Let me get the port number. So you can use it directly from the UI if you want to. There is a nice UI to convert documents. So if you want to try out, you can pass a URL or a file. All these options are available through the Docling Java SDK. So whenever you integrate with Docling, you can provide all these options. And I hope in the future to share also some nicer integration for Spring AI. This is all very experimental right now, what I'm showing you, but I hope I can publish something more concrete soon. Now, the last thing I want to mention for this presentation is how to not only augment our prompt with data, but how to integrate our application in general with APIs. So far, we've been working with data. But I mentioned at the beginning that Spring AI also lets us integrate with APIs. So that's where tools come handy. So what do tools have to do with this Spring AI flow? So whenever we send a question, we can tell the model that we have some APIs available. We are Java developers, so APIs could be methods. So maybe we have some Java methods in the application that we want to make possible to call based on a decision made by the model. So the model can tell the application, hey, I can see you have this API, please call it for me. That's what we call a tool execution. So the application calls that Java method with the parameters that the model defines, and then the result is sent back to the model. And then we get back the answer. So this is slightly different compared to the previous case, because in the previous case, we were always retrieving the context. In this case, we are just letting the model know about what possibilities our application has. And then the model decides if and when to call each API. And a tool, it can be just a simple Java method. So in here, I could create a class called my tools. I could make it a Spring component. And then I define a method, maybe get local date time, perhaps, that has no argument, but return the local date to string, like this. Now, this is a simple Java method. If I want to turn it into a tool, meaning that I want to make the model aware that this method exists and can be called, I'm going to annotate it with the tool annotation. I'll define a description so the model knows better when to call this tool. So in this case, is retrieve the current local date and time as a Unix timestamp, something like that. Now I need to tell the model that these tools are available. So I'm gonna grab this object here, and we're not using advisors anymore for now. So I can pass instead some default tools, and I'm gonna inject my Spring object that contains my tools like this. All right. So now every time I call the model knows that those tools are available. So what can I do with it? For example, I can ask, what time is it? The model doesn't usually know that, right? Doesn't have access to current information. But now it can tell me that the local date is November the 25th. Weird, I ask for time and tells me the date. But anyway, he called the model. He called my Java method to do that. And I can prove it to you because I have observability in place, which is really nice. So let's see. We have the original question, what time is it? Now, when we are calling the model, you can see now there's not only my input message, but Spring AI will augment the request to the model with a list of tools that are available for the model to call. So we have here a definition of my method, which is called get local date time. There's no properties because there's no argument, and the description. Now, the message or the model realizes that my question requires knowing the local date and time. So we can see that it says it doesn't answer, but it actually requests a tool call. It requests the application, please call the get local date time method for me with empty arguments. We can see that Spring AI calls the method for us. We get the output back. And finally, we propagate that output to the model. So the model now can finally answer. So that's tool calling. And we can do it in order to integrate our own APIs or even external APIs. For example, we have MCP. You might have heard about this model context protocol that allows to consume APIs that are available over the network. So those APIs don't need to be part of our application, but we can use MCP as a protocol to call other types of APIs. Now, the last thing I want to mention is how we can combine these tools for an agentic behavior, because instead of having separate chat clients for specific purposes, like I have this one for tools and I had previously one for doing retrieval-augmented generation, what I can do is define each of them as a tool. Where is it? Here, tools class. So I turned every one of the previous examples into a tool. For example, here I have my chat client that retrieves context from a search engine. I put it in a method and annotate it as a tool with a description, retrieve information by searching the web. I have two more tools to retrieve information about my stories from Vector Store with different parameters. So now I can use these tools into what we call an agent. So our agent here, I can replace that with the other object. So now this chat client here will act as an agent, meaning it will decide, it will take decision about which of the tools to call. Should it use a search engine? Should it use, it's here, should it use different types of tool, or perhaps it should use the internal knowledge that it has based on the trained data. All right. So that was the last thing I wanted to mention. Thank you very much for joining. I think we can open up for questions. All this code is on GitHub. I'll share the slides afterwards. The part about Dockling is brand new, so I will probably publish that in a few days. But I'll, yeah, keep you posted on my social networks when that happens. So thank you.
All right. Let me see some claps. Just like need some claps, reactions, and everything. That has been fantastic.
Thank you.
Yeah, 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 yeah. I know. I don't know if we have questions. I guess I bet we should be having questions. And before questions, thank you so much, Thomas, for the insightful presentation you've done. And it quite like touches a lot on the surface level things we sort of like I myself like most of the time touch on Spring AI, but at least I now have like an in-depth understanding. So any questions? So we could have hands up so that we have the questions for Thomas. Yes, Michael.
Hello. My question is on memory. So I was reading about different implementations of memory, like episodic, procedural, and that kind of thing. Which one is the Spring AI implementing when you use memory?
Yes, thanks for the question. Right now in Spring AI, we have this chat memory interface. So earlier I added this chat memory object. Now this interface uh, is very simple. It has just a few methods in order to add new messages to the memory and retrieve them. But the implementation is what is really key for a specific use case. Uh, by default, Spring AI has an implementation called message window chat memory. Message window chat memory. So this implementation, what it does is that it keeps in memory the last, I believe, 20. Let's see. Yes, the last 20 messages. So whenever we have more messages, it will drop the oldest ones. That's because we need to consider performance. We don't want to add the entire conversation in it. Now, this is a good default to try it out, but in a real world use case, we need more advanced solutions where perhaps we can summarize the past messages and include a summary into the memory. So I would say out of the box, it's something that works very well for simple cases, but in more elaborate use cases, I would recommend considering what kind of strategy is needed here. I hope that in the next major of Spring AI, we can add a bit more advanced capabilities to the chat memory, because right now the chat memory is specific to handle memory, but we also have use cases where you want to keep the history. Like the chat history is actually keeping the full conversation stored, whereas memory is more focused on what context do we need to add to the next interaction with the model. So I hope we can solve that difficulty we have today in handling both memory and history through the same API. But for now, chat memory is very focused on that runtime capability of retrieving relevant conversation and include it in the prompt. Uh, I hope that answered the question.
Yes, it answers. Thank you very much.
Thanks.
All right. Thanks, Michael, for the question. Do we have any other questions? So we have like 3-4 minutes. Do we have any questions? Any questions? And as I wait for them to ask the question, so I have a generic question, Thomas. You are
Yeah.
building an application that integrates Spring AI in it, and say for example, you're dealing with an application that has, you're dealing with, it has customers, it has like various users, and you want to say for example enable the admin side to be generating reports, and also you want to integrate say sort of like a simple chatbot for the same. So there are various approaches you could say for example use for the chatbot and also like for generating reports. So when does one know when to use say for instance RAG, or when to use tools, and yeah, how does one like draw a clear line between these implementations?
Yes, that's a very interesting question. For the user-facing part, like a chatbot, that's probably the most complicated thing to get production rate because it's easy to build. Like the chatbot I built is very easily done, but we need to put in place lots of safety measures because models are non-deterministic and it's very easy to change the instructions for a model. So we need to build, for example, using advisors, adding some guardrails. So we can define some advisors that are guardrails that can intercept maybe malicious inputs from the user, but also make sure that we are sending back correct output. But we have lots of different ways to integrate AI into the application. So you mentioned, for example, reporting. So I would expect that to happen asynchronously or in the background. So we can use a tool like Job Runner, which is one of my favorite tools for running tasks and schedule jobs that can run in the background and use these APIs in order to retrieve to generate reports. About retrieval augmented generation, if you want to be able to make your customers' data part of a retrieval augmentation workflow. So, for example, having customer performing semantic search or asking questions about their data, that could be done synchronously. So whenever you save some data from the user, you also generate the embedding and store that, or possibly asynchronously. So still having some scheduled job in the background that process new data and need do all the parsing that need to be done, and then store it as embedding, so that whenever the user wants to ask questions or wants to interact semantically with that content, we already have all the vectors in place. So there are different ways to expose this functionality besides the chatbot. So it could be categorizing some inputs or to help, even filling out form. So maybe I can pass an audio recording or I can talk to the application and get everything I'm saying transcribed and fill out the form automatically, or maybe upload an image of some notes I took, and then I want to get them in a structured format. So again, I can use that approach in order to get some AI capabilities. So there are different ways. My suggestion overall is to consider the user experience. So starting from the user experience, meaning what requirements or what capabilities I can offer the users that would make their life easier or would make my customers happier. So I wouldn't start with where should I put AI, but I would turn that question around it like, okay, I consider my current requirements and experience I'm offering my users, my customers, what can be improved? And at that point, consider where AI can fit in those scenarios. I hope that makes sense.
Yeah, it does totally. Thank you so much. Okay, do we have any other questions from the audience? So let me just see if we have any in the chat section.
Yeah.
Yes, William. So possibly the last. Yes, William. William. Okay. Seems like we can't hear you, William. Or can anyone hear William?
Okay, thank you.
Okay.
I'm sorry I had muted my mic. I have a question, and I'll be quick. How can we optimize latency and throughput when calling LLMs from high traffic Spring microservices? Because I think it's a very big challenge I'm facing currently.
Yeah. Also, very interesting question. Um, yeah, there's no simple answer to that, really. There are different ways or different things to consider. For example, for specific tasks, it could be possible to use more specialized models. For example, the embedding operation that I've been doing in this application is using a dedicated model. It's very small, it's very fast, and is performing very well just for doing embedding. So there might be also different types of models for specific tasks where latency is important that could make a difference. So choosing the right model, I would say, as one thing to consider. Choosing where to call the model from. If it's on premises, it's important to consider how to where it's running, so how to optimize the path to the inference service. You could consider adding what is called a semantic cache. So whenever we ask a question to the application, we could store the response as embedding. So using the same approach as with the retrieval-augmented generation, we could store previous question and answers so that the next time someone asks the similar question, like what is Java, I'm not calling the model every time, but I can retrieve the response from my cache. So of course, this is something more advanced than the normal cache we are used to, but that's also a possibility. And another possible aspect to consider is how big the prompt is, so how much context we are adding, because the more we add, the slower it will be, because the model needs to process all of it. And if it's a cloud one, that also means, of course, higher cost, higher number of tokens used. So there are also other benefits in optimizing the content of the prompt. So when doing RAG, for example, I want to tune and refine that semantic search so that I only retrieve the information that I really need and not extra, both because of latency and cost, but also because the more information, the more likely the model is to maybe miss out on some important information, because there's a lot of noise in the prompt. So that's just a few things, a few aspects to consider on top of my head, but there are more, and it's more nuanced than that. But I hope, as a short answer, that it made sense.
William, so I really hope that was answered. I I guess we are past time with like 5 minutes, and we just like have to do the honors of appreciating Thomas for um, having like creating time to talk to us about Spring AI and the various ways we could use Spring AI in our applications. So I just like urge you, if you're comfortable or if in a position to do this, you could post about the session, what you've learned, either on X or LinkedIn. You can tag Ian or Thomas, Kenya Jag, and anyone else you feel like possibly somebody you brought into the session, so that people get to learn more about Spring AI and the massive things it could do when building applications. So finally, Thomas, I'd love you to talk about Aconia in a minute, and then we can wrap it.
Yes. So very quickly, Arconia is an add-on on top of Spring Boot. So I really like working with Spring Boot, but I found myself creating some additional improvements in terms of developer experience, or maybe features where I was constantly copying and pasting boilerplate code across my application. So I decided to consolidate all of this in a library, and also made it available so that others could benefit from it. So it's an open source project. You can find more information on arconia.io. There is a CLI to also simplify the way we interact with Spring Boot application. Some of the main features I mentioned, dev services already. So you get all these nice services running for you when you run the application. We also indirectly saw the open telemetry capabilities. There are more. The recent one is about Dockling. I'm planning to add more features. And if you give it a try, I'd appreciate if you share your feedback, your inputs, or maybe something that is missing, something not working, or something you would like to see part of the framework. I'd be happy to consider that a fully open source project. You can find us on GitHub. And yeah, that was very brief. I want to thank you for inviting me, and thank you all for joining. I had a good time. I hope you learned something new about Spring AI, and really feel free to reach out to me. I'm very active on Blue Sky and LinkedIn. So if you have questions, or if you'd like to, have a chat about different topics, you'll find me there. Thank you.
Okay, thank you so much, Thomas, for honoring the invite, and thank you everyone for joining. Remember, if you post, tag Kenya Jag, Thomas, and just share some screenshots of what you learned or took from the session. And that marks the end of the session. Have a wonderful night. Bye bye.
Bye.